testing. No crawfish. Your brains are really
Crawfish.
good.
Oh, brains? No, you suck the heads, but you don't eat the brains. We're talking about crawfish. We're not talking about something really.
Couple zombies over here.
Couple of zombies.
Have anyone watched Duck Dynasty back when it was still
Way back in the day, huh?
She has a cookbook and stuff, and one of them was squirrel.
Oh, my daddy.
It's just disgusting to me. Anything's brain, if it's not its intestines or like body and muscles itself, like a chicken.
I don't want to eat intestines either. All right, well, let's real quick. I want to go over a couple of things. Just listen for a minute. Then I'm going to give you out your next 9 weeks worth of work. We're going to put them in our binder to be organized correctly, and then we'll move on. What you got? Question?
Lesson 9.
Yep, it'll be lesson 9. Okay. Yes.
I found a brownie point.
Ooh.
In constant, there's like a space
Between the teeth.
Oh, so that's 2 because somebody else.
I saw one too. I saw one too. It was in the text. It was in the text.
Yes, that's where it was. That's where the other one was.
Yeah,
I have 2 in the test. So what are
Yep.
1?
That's right.
Well, I found 8.
9.
There was a question I saw in the test that confused me a lot, and it made a lot of my time go down.
Okay.
But you were gone.
Oh,
so
you couldn't ask me? Okay, what in the heck does it
So
say?
the question was, it was something to do with force, and it was, which one would do something, a moving truck or a minivan?
Yeah.
Oh, and you thought it meant a moving truck, not a truck. Oh, I see what you mean.
Not like a
Okay.
truck that, not like
I
a
felt
big
like-
truck that you used to move.
All right, well, I'll look. That's a good
I
point.
thought that's what it meant, like the truck you use for moving.
For moving, yeah, that's what it meant. Yeah.
Yeah,
So
I
I'll go
didn't think
check that and make
I
sure
thought it meant
everybody
like an
got it.
actual moving car.
Well, it said minivan and not
Minivan.
a moving van.
Yeah.
I'm like,
Right.
okay, so that must be.
Like,
All right, so let's look over real quick. These are things I reminded you of in the emails. Everybody checking their email? Gotta check your email. All right. So,
I just don't understand it.
So I mentioned that everybody should be checking their grade book. Make sure they're not missing anything. Turn it in today if you are, because it's the end of the 9 weeks, right? And that, what are we doing next week? What's going on next week?
The fair.
No,
That was.
we're out of class.
I'm
No.
not going to the fair.
Yeah, there's an online class next week. There's no meeting next week because we are going to be in Ireland by this time next week. Or no, will we still be in Scotland on Tuesday?
I'm not sure.
I don't know.
Holiday trip, that's all I know.
Yeah, I don't know which day we're moving. This is like the only thing I'm not planning.
When you're moving? You're moving?
No. We're not moving.
just moved.
We're
like
just
3
visiting.
years ago.
All right, so you get your new binder material today, and reminder that, you know, it could be Tinker Day at some point. So if Tinker Day happens while we're gone, I'll bring donuts for you guys when you get back. Everything is going to be due, and we're going to look at this in a minute when I hand you your stuff. Everything is going to be due when we get back. You don't have to turn in anything over the next 2 weeks. Nothing is due till the 29th. So,
How will we do our lab?
So I'll show you. It'll make sense to you. All right. So, let me close that. And I'm going to go. Okay. So first things first, let me hand back some things I have. This is you and Trev and another Trev and another Delia and another and another Delia and another Delia. Got lots of Delia. Okay, does anybody know whose this is? Anybody want to claim it? Yep, pass it around. See if anybody claims it. No.
Probably me.
Eleanor, and Eleanor, and Eleanor.
No, that's not.
These are all for Eleanor when she gets.
Actually, it might be.
Okay, now.
Me and something.
All right, yeah, you didn't have anything to hand back. I'd already given back whatever you'd given.
I'm actually not sure. This might be mine.
Okay, so here's what we're gonna do. Listen, I'm gonna hand you this. Do not unclip it till I tell you to unclip it. Okay? One for you, her, one for you.
That was really weird. I'm sorry.
One for you.
What are you talking about now?
One for you, Traveler.
Oh my gosh.
Drew, here you go.
I thought this was a lot, but
Whoa, what the heck is? You can keep this.
No, if you really want to. All right, and then this is. Mixture.
What the heck?
Oh, yeah,
Can we take out
Jackson.
all this
And what?
and then put this?
Okay, so wait, I'm gonna tell you what to do. So wait, don't unclip yet. I'm gonna tell you what to do.
Yeah, Trav.
I
Alright.
didn't.
All right, everybody watching here. That must be Eleanor. Let's see. Is that you, Eleanor? If it's her, I want to wait a second. Is that you, Eleanor? Hey, good timing. Come on in. Perfect timing. Go ahead and come on over real quick, and you can put your homework and stuff up in a minute, because we're about to put our binders ready for the next 9 weeks, so I want everybody to know what we're doing. All right. You're bizarre. Why are you walking that way? It's okay, babe. All right, so get your binder out. You're gonna need your binder out, right? All right, so here's what we're gonna do. Everybody's got this, right? Okay, first thing you're gonna do is unclip. If you really wish to keep the clip, you may, but if you do not, toss it in this box of clips, or throw it on the table so you can make it to the box of clips. All right, that's step number 1.
I never
Drew, unclip. Wait for you.
I know it's just gonna go all over the place.
No, it's not. That's the whole point. Okay, the next thing I want you to do is I want you to look. You've got paper clip section on the top. You see that?
Yeah.
Okay, this is your syllabus. It's your entire syllabus from the beginning again. Okay, so what you need to do is go to the front of your binder
Oh god.
to where your syllabus is. Should be in the very front.
Syllabus.
Leave all the rest of this big stack off to the side.
Does it?
So go flip, flip, keep flipping, Lily. Don't pull anything out yet. Just flip till you find it. So it'll look like, I'll show you in mine. You're gonna have, you know, your first page. Whoops, don't mind that. That's an extra fun thing. Right? You flip,
I found it. I found it.
flip,
Does it? Yeah.
flip. It looks like this. You see it?
Yeah, we found it.
Okay.
Should we clip it in?
Look, wait a minute. Take this until you get to the page that says Q2. It's like 3 pages, I think. Take all
Where would
of
it say
those
Q2?
out.
Where would it say Q2?
Just flip. It's like on the 3rd page.
Oh, I
Take
know
all of those pages out.
all this. All the ones that say.
Yep. Not everything from the beginning. Just the ones that say.
Wait,
hold
what
on.
about the final project?
Nope. Just the ones that look like. Okay, wait. It's this. 1, 2, and 3. Take those 3.
Yeah,
Okay.
Q2.
You know which 3? Let's find your 3.
Which one's Q2?
It says
Oh,
Q2 on
Yeah,
one.
Q2.
Mine says Q2 on the very
Oh,
bottom,
you
like
need
the
that?
middle of
We'll leave
the
this
page.
in
Yeah,
One.
there's 3 ones. Q2, this one, and this
I don't
one.
know. You might
These
be wrong.
3?
All right, wait.
They'll say
Okay.
what, but you-
Take this paper clip section here.
Come on, these 3? Supposed to say Q2. This
No,
one.
the
This
ones
says
in front of
resources.
Q2. Yeah, not resources.
These 3?
Those 3. Show everybody what you've got, Savannah.
Oh, I've got
Those 3. They all say, look at the bottom. They say syllabus 1, syllabus 2. See they're numbered?
I have like
Yeah,
4
Charlie
and
has
5.
Oh, I got syllabus.
You got
3.
extras, right? So yeah.
You got
All right.
stuff.
Take all those out. Then you're going to take this right here, this new section. All right? And you're going to clip it in.
What the heck? I don't have any that say syllabus. I have one that says syllabus. One page. That's it.
No, let's see. You have it all. I'll make sure you got it.
Should I put it in?
Yep, go ahead and clip it in.
Do I have to take the paper clip out?
Wait a sec. It's going to make it easier if you wait 1 second before you do that. 1, 2, and 3. Okay, these come out. Okay, those go in. Now, with your paper clips still in. Okay, so everybody have it? Good. With your paper clip still in, you can flip to the last page. You can take it out whenever
The
you
very,
want.
very last
But
page.
it's easier. Hey, there she is. Come on,
The
girl.
last page of the binder.
No, the last page that's paper clipped, right?
Oh.
Okay, Sky, this is yours. So here's what we do.
So this
Yeah,
page.
so- Hang on a second. So flip right there. Okay? So Sky, if you go to the syllabus right there,
So look
at the
here,
very
paper
beginning,
clip. This.
go to like, it's like the 3rd or 4th page in. Keep going.
No. So I
One
take
more,
it
I
out. Wait,
think.
no, taking out. Oh yeah, this one.
Let's see.
Wait.
All right, the page on your right. The one on the right side. There are 3 there. 1, 2, 3 on the
No,
right.
not yet.
Take out those 3 that look
This
like
one.
your
Little
lessons.
lessons.
Okay? And you're gonna replace it. That's it. Perfect. 1, 2, 3.
Yeah. So she just said
Perfect.
you
And then you're gonna replace it with that one too. Yeah. Good. And replace it with this right here. Okay. All right. So if you look at this last page, this is what I'm trying to show you. If you look at the last page that I just gave you with the paperclip, it looks like this, right? It says altered class schedule. Everybody see that?
There we go.
I want you to look at that real quick. Okay? Because this is for lesson 18, which is the last lesson of the semester. Okay?
I don't have it.
And yeah, you do. It's the very last page of the paperclip that you just put in. Did you put the new ones in, or did you just take the old ones out? Oh, put the new ones in. There you go. You did? Let me see. Oh yeah, let me look good. Oh, wait. Just go somewhere else, but okay,
Sorry,
it's all right.
my mom does
You're
that a
okay.
lot.
There you go.
Gotta get things.
Right there. Got it? Okay. Notice that this class has a different schedule. You guys are the same, 10 to 10:45, but then the other group, they're coming in from 10:30 to 11:15, and we're going to do like a midterm. Okay? So it'll be a test, and this will be a pencil paper test. Don't freak, because if you need extra help with writing or spelling or anything like that, I will gladly help you with that. But it's going to be not on computer, so you'll be here. You're going to come here and do it here. It's not high stakes. It's not high pressure. It doesn't weigh more than any other test. Okay? So, yes.
My ours look like plants.
That's fabulous. Yeah, yes.
It's due Monday, right?
What, this?
No, like I meant the
When
test.
Yeah, well, when we do this, we're going to do it in class. It's the last day of the semester, so it's December 17th. Yeah.
I still need to do the online test.
There will be one for your, this is separate, but it's for the whole semester, okay? And it's high level, so it's not nitty gritty, like the stuff we do every week hits on more details, but this is more broad for the whole semester.
Like everything we've learned from.
Yeah, but the important stuff, right? Okay? And it's not going to be long because
like, what
look.
is Newton's first law?
Yeah, exactly. Like you won't have, what's the difference between a theory and a law? What's Newton's first law? What's a hypothesis? What's a controlled variable, right? That kind of thing, big stuff.
What is it? No.
All right, so the other thing I want you to notice is your assignment for that day is to bring in food for our party, okay? We're having our party that day.
I want to make mini brownies.
Well, there's certain, we'll go over it as we get there. All right, so the next thing I want you to do is, listen, flip to the very back of your binder. Very back, flip, flip, flip.
To the backpack of the binder?
The backpack, yep.
We're going back to the future.
The very last page you have.
Back to the future.
All right.
I turned my pages while my syllabus was open.
Very good. Go flip the very last one. There you go. All right, Drew. When you get to the very last page, you're going to take the big stack I gave you. And you're going to lay it right down there on the right, okay? Open the rings up and stick it right in. So open these rings. Watch what I'm doing with Eleanor's, okay?
You put it
Here it is. See it? And you're going to stick it right there so that you can still see it, because we're going to talk about it for a second.
This piece right here, the one that's supposed to 10.
Yeah, but it's not just, it's a whole stack, honey.
Yeah, it's 3 pages.
Yeah, the whole stack I gave you.
Oh,
The
You
whole
may have
stack.
to give me a minute. I turned my pages with
That's
my
okay.
binder clip open.
Take your
Now
time.
everything came out.
That's okay.
It's like a waterfall.
And you open it up when you put it on at the very last page.
The very end. All right. There you go. That's not the end yet, Drew.
Oh.
Whoa! There you go.
Put it right here.
Yeah, put it exactly there. That's exactly right. All right, so now what I want you to look at is, this is your lesson for next week. Okay? Angle this down so Jackson can see this. This is your lesson for next week. It says lesson what? 10, right? Okay. Now, lesson 10 is online. It says it on here too. It even says, look, no weekly questions next week. You don't have to do that. And then what you're going to do is you've got some stuff to read in your book, right? You've got some notes to fill out, and then you have a list of videos. You know that if you go into Teacher Ease, you can just click the links, right? Okay, and this is like your lab, correct? Okay, so once you do that,
Questions on number 10.
no weekly questions for number 10. All right. Now, if you flip 3 pages to lesson 11, I just want to show you lesson 11 real quick, and then we really have to get on with today's lesson. You see lesson 11?
Yeah.
Okay, lesson 11 is a little different. This kind of is a lab, but you're going to do it by yourself. It's less a lab and more kind of like a little experiment. You've got Newton's third laws there, and what you're going to do is you're going to pick one of these quote unquote tricks. Okay, they're on the back of this page, and you're going to, it says right here, demonstrate it for a friend or family member, then answer the following questions online. So you're going to go online and you're going to look, and for this assignment, there will be these questions, and you're going to answer them. And the questions are, which experiment did you choose? Why did you choose it? which of Newton's 3 laws was demonstrated, and explain how the trick demonstrates the law. If you look on the back, these are the tricks. And it's fun stuff, like quarter flipping, demonstrating a crater. There's all kinds of things. You can try any of these. Crater. Like making a crater. There's instructions for every one of them. Okay? Once you leave here today, everything that wasn't due at the beginning of this class is due on the 29th when you come back. And nothing is due on, I mean, even your online stuff, like your test for this week and your questions that go with this experiment, all of that is still due the 29th, even though it's accessible already. Yes? You got it? What don't you get? Where are you lost?
I'm lost where you said like the 29th.
Okay, everything is due the 29th. After today, after today's questions that you hand in, everything else is due on the 29th, because that's when we come back to class. We got 2 weeks off.
So what day is the 29th?
2 more weeks.
Okay.
Okay, all right, one last thing, and this is going to be probably the trickiest part.
I
Okay,
was lost because
I want you to flip to lesson 12. Okay, that was lesson 11 we were just on, right? So if you flip to lesson 12, all right, and turn to the back of lesson 12.
Wait, what?
If you turn to page 6 of lesson 12, you will see that there was a misprint. Rico's on the wrong side.
Whoa.
So here is your replacement page so that you can hand in Rico.
I don't see it. Look.
Keep going. There you go. That's where he goes. You've got it right spot. Click him in there. I swore I had it lined up correctly, but apparently I did not.
So get rid of
Delete. Keep it all in there. Don't get rid of any of it because it's got a lab on.
Here, so I put it right here.
Yeah, baby, right there. All right. Yep. Keep going, Drew, till you see Rico. Put that right in front of Rico. Cover him up with it.
Rico!
All right.
What's up? What's up, bro? What's going
Yeah, I printed this myself, so it's different.
Oh, I didn't get What's the
I
thing?
have one. I'm wondering why I have an extra here.
What's the thing for Rico?
It's on that side. All right.
Fighter pilot. What is it?
Now we got to get to today's lesson.
Fighter.
Fighter pilot.
It's a fighter pilot. Fighter. It's a fighter. That's what I said.
Yeah, I knew.
I thought it was a fighter.
Yeah. All right, let's do it. Let's do today's lesson. So go ahead and get yourself flipped back to today. Okay?
Today.
Today's lesson.
It's like there's no time like the present when this favorite part of the day.
Share my screen.
Yeah.
All right.
That's it.
All right, so first thing I'm going to do is I'm going to do a little, where did it go? Oh, a little experiment, if I can find, here we go. All right, so this lesson was on what? Friction and gravity.
I can't find my
Okay, look for your folded. Uh-oh, where's that part? That goes in the very beginning, right? Okay, that stuff's the stuff that goes right at the front, sweetie. You got it there? All right, there we go. Okay, so
Did this also go on it?
what is that? This is the one you took out, right? Yeah, this is the one you
These
took out.
are the notes, right?
You've got one that you took out. You can ditch it over here. What's this one? Lesson 10.
Wait, what am I supposed to take out? What am I supposed to put in?
I don't know. Huh? No, what? I'll do with you later. You're fine. Okay, so look, we got to get to our lesson. So here we go. I have in my hand a quarter and a dime.
Okay.
Okay.
Oh, like my dad always uses me for keeping this.
Should be right here where this is. So we're on lesson 9. So that's 8. So keep going. Keep turning. Keep turning. Keep going. There you go. You got it. That's 9. Okay, so here we go. If I take the quarter and the dime, and I'm going to put them up here. Let me turn this. Okay. And let me actually make that big again for Jackson. Come here. No. Come on. All right. If I take this quarter and this dime, and I put them right here, and I knock them off the edge, I'm going to put them down here where everybody can see it. All right. Do you think they are both going to hit the floor at the same time? Is one going to hit for the other?
No, they're gonna hit the floor at the exact same time. Because
Same time?
yes, the second.
Okay. Same time? Anybody else have a different vote, or everybody agree with same time?
It's the exact same time.
Okay. If you can't see the floor, stand up so you can see the floor.
It's like if we're gonna try
Ready?
everybody's like standing up.
Yup. Good.
I think the quarter no cancer. No.
Great.
I think it's
3, 2, okay. Ready? Quiet, watch. Alright, So what do you think? Did they hit at the same time?
Yeah.
I think they hit at the same time. You want to do it one more time to be sure?
Yeah.
I mean, I heard one big bang when they hit, right? One click, right? Let me get them all lined up here. You ready? Well, that time I didn't knock them off right. My little ruler got stuck on my chippy mantle.
Come on, just hold one on one hand and one on the other.
No, this is better. Okay, ready? There
They
they go
hit
again.
exact same time.
Exact same time. All right.
It's
So,
like if you have a watermelon and an egg and you drop them off the deck, but it's the same thing.
Yeah. All right.
Anyone else had a project that you're trying to protect, make something
Hold
around the egg to make it not? Well, when we were testing it with the egg,
Oh, egg drops.
my
Yeah.
brother Lucas chucked it down. He literally he threw it down.
Threw them, huh?
hard. And the egg didn't work.
All right. So let's look at our notes. All right. And I've got one more little experiment to show you as we get going. So friction is a force that grows through that one. I'm right with you. We've had terrible allergies around here. Like it's bad.
Awful.
Yeah.
Sorry about it.
Friction is a force that one surface exerts on another surface when two surfaces rub together. So do this, right? Rub like you're Mr. Miyagi. Do you know that reference?
Or you're cold and you try
Yeah.
to create.
Well, what do you feel, right?
Heat.
Right, heat's coming from the friction. Excellent. All right, do you like this? Wait, do you like this? Put them together very lightly. Try to move them. Okay, now put them together really hard and try to move them with the same amount of force. Yeah, it's not as easy and kind of jerks, right?
That's how hurricanes start, basically.
Yeah, with the
Earthquakes.
earthquakes. Yeah, there you go. All right, so all objects.
Continental plates rub together like that, and then they
Yeah,
shake
that's
it.
right. That's exactly how an earthquake goes.
Who just likes
So-
metal?
Let's move on. So all moving objects are subject to what? Friction. That's going to be your first blank, right? Friction. The strength of the force of friction depends on two factors: the types of surfaces involved and how hard the surfaces push together. So when we did this, we were pushing them together harder, right? Now what if one of these, what if we whenever there got some like Crisco or something from the kitchen and slapped it on our hands and we still pushed them together hard, would it be easier or harder?
I don't know. I think
It would be. Crisco is grease.
It would be easier.
Yeah, because we
like powder. And I was like,
Nah, oh, that too, that could depend. Yeah. So the strength of the force depends on the two factors: the types of surfaces involved and how hard they push together. And of course, how hard they push together could be how gravity affects them, what forces are coming from the outside, right? Sides, up, down, all kinds of ways. So your book mentions 3 different types of friction, but it doesn't cover another important type of friction that I'm going to bring up with you guys, right? So there are actually 4 main types of friction. All right, so you've got static
Can I
friction.
say it?
Hold on. Oh yeah, you want to do it? Read it.
Yeah. There is static friction,
Mhm.
which is like something like falling down, like a.
Yeah, it's like that. It's friction of
Then
staying
there
still,
is
basically. Yeah.
sliding friction, like a
Uh-huh.
ice skater.
Right.
There is rolling friction, which is like
Mhm.
a car. And then is this the one that you wanted to say? The other one?
No, the fluid friction.
Yeah,
which
then
one
the
did
fluid
your-
friction.
Which one did your book not have?
Static friction.
The static friction. Okay, so static friction is basically
Fluid
if I-
friction's like a meteor.
if I put this here and I tip it a little, it's not sliding, right?
No.
Not yet, because it doesn't have, gravity's not overcoming the friction yet. But the more I angle it, sooner or
It's
later,
fine.
the gravity overcomes it.
Mark Rober told me.
Rober told me.
My best friend.
Yes.
That it's because the weight and force pulling down on it from
Uh-huh.
the Earth's core
Uh-huh.
is more like if you're gonna have an arrow, the arrow is bigger on this side going downwards than it is on this side going
Exactly. Very good. Very, very good. All right. So you got sliding, rolling, and fluid in those 3 blanks. And then the other kind was static. And your book didn't mention static, and it really should have. So then we go, what's the next paragraph? Anybody want to read the next paragraph?
Why didn't it tell static?
I don't know.
And it's a science book.
I know. Sometimes it leaves stuff out. Does anybody want to read the next
Read
one? Traveler does. Okay, listen, Trav's going to read the next paragraph. Go ahead.
Gravity. Gravity is the force that pulls objects together. And then on Earth, gravity acts in a downward fashion pulling on all objects to the center of the Earth.
Very good. Sure. Anybody else want to read the rest? Savannah, go ahead.
When the only force acting on an object is gravity, the object is in free fall.
Free fall. Good.
Gravity also acts on objects that are thrown horizontally. A thrown object is called a projectile, while an object that is simply dropped falls in a straight line. A projectile that is thrown horizontally will fall to Earth in a curved line.
Perfect. All right. So when you think about it, we talked about this a little bit last week, I think, too. But when you throw a ball, it's going to go in whatever direction you propelled it, but gravity is going to also be fighting it, and it's going to come down. So it's a curved path. And didn't we talk about this last week, that sometimes curved paths are wide and sometimes they go straight up and straight down, but anything you're throwing up is going to come back down. And for free fall, it's just like if you were to drop the ball. Man, that ain't going to happen. You drop a ball, unless it's a rocket, you're propelling it out.
Yeah, I was gonna say, like fighter jets on an aircraft carrier, they shoot it with a slingshot, and those are that one has
they do, but they also catch it with a cable, and they come back. All right, so let me read the next one. Some objects fall at a much faster or slower rate than objects of similar mass. Air resistance is a type of fluid friction that impacts how object falls or travels through the air. The greater an object's surface area, the greater the air resistance. Air resistance increases with velocity. When the force of air resistance and the force of gravity equalize, a falling object's velocity stops increasing, and the object will fall at a constant velocity known as terminal velocity. Right, okay.
It's like
So-
how parachutes work too, because they have a big surface area. That's
Yep.
Every time we get an answer right, I'm just going like,
Right.
So
So,
if you're gonna drop an anvil and a big dart, the
yeah.
dart's gonna hit the ground before because the anvil is floating.
Right. So I want you to think about a skydiver, right? When he jumps out of a plane, he's got a backpack on. And what's in the backpack?
A parachute.
A parachute. Okay. So, yeah, 2 parachutes.
And
True.
then none of them fly, and then you
Okay.
just
Drew, don't interrupt. Okay. So let's say he's jumping out of the plane, all right? And he's got his backpack on, and his parachute is in it, okay? And he jumps out and makes himself straight as an arrow, okay? What kind, describe his velocity to me. How do you think he's going to be moving?
He's going to be going downwards really quickly.
Really, really quickly. Good. Okay, wait, stop there.
Faster than before.
What would he need to do if he wanted to slow down but not super slow down?
get
Yeah.
make himself have more surface area.
Right. Make himself have more surface area, spread out real big, and that will slow him down some, but not entirely, right? What does he have to do if he wants to slow down and not smack the ground?
Yes, turn on the parachute.
He has to deploy the parachute. And what does the parachute do? Did he increase his mass in any way?
He didn't decrease his mass, but
Because it's still attached to him, right?
Yeah,
Right?
it's still attached to him no matter what. But
Right.
it creates more surface area.
Surface
more wind
area.
push up against it.
Right.
So there's more. So when you're falling
Mhm.
down, you do have some arrows pointing upwards.
Yeah.
But there's like most of the arrows are going downwards.
Right.
But
Right.
when you pull it up, the arrows that are on top of you go up way.
Right. Right. So slow down. Yes.
Yeah.
All that air
It's
resistance.
like a helicopter right here. It's hovering because it's equal to right here.
So the force of gravity on an object at the surface of the planet. What do we call that? What do we call that?
What do we call
The force of gravity on an object at the surface of the planet. Weight. Okay, because the weight has to do with mass, but it has to do with how gravity acts on that mass, right? So things with more mass are going to weigh more or weigh less? They're going to weigh more, right? Okay, what about if I had a giant sponge?
That's actually not necessary.
No, at the same place on Earth. On Earth, that's what we're talking about.
Well, I mean, you can have something that has more matter inside of it, but doesn't weigh as much as something else.
Well, then it wouldn't have different mass. That's what we're talking about, is mass stuff. So what if I had a giant sponge, okay, and I had an equally sized block of clay? Which one is going to have more mass?
By far the clay.
The clay, because the sponge is full of what kind of matter?
Dark water.
Dark matter. Well, not a wet sponge, a dry sponge.
It's
Good
going to
point.
have lots and lots of holes inside of it.
What's in the holes though, Jack? What's in the holes?
Or
Foam, and what's in the open spaces?
Air.
Let him answer. Air. Okay, right. So you got air.
I
So
think that is
air has mass, but it doesn't have as much mass as clay, right? Okay. So what's the formula for weight?
Formula for weight equals mass. I think it's mass times. I won't say anything. Oh, weight equals mass times acceleration.
Right.
Due to gravity.
Weight equals mass times acceleration, and that's due to gravity. Usually that's done as a small a. Okay, so when you get on a scale and it tells you how many pounds you are, that's what it's telling you. So what do we measure weight in? In the US, we use pounds, but what's a scientific measurement for weight?
Ounces.
Nope. No. Grams is going to be mass, but what's weight?
What the heck? Ounces.
Oh,
Newtons, Jack.
Oh my God. I
Newtons.
thought Newtons was force.
It is, but that's what we're dealing with. Weight is basically force. It's the force of gravity. So weight is measured in newtons. That's your blank at the bottom. You see that? Mass in kilograms or grams or whatever.
I just picture that because some people say, like dinosaurs and whatever, they say in pounds how strong their jaw is. Like,
Yes, because it's force.
yeah, because like
Exactly.
you're gonna put a pound of one thing on one pound, so I know
Right.
that's how heavy they are.
They also say
So there's
pounds
something
of
called
pressure.
a foot pound, and how many pounds of pressure?
Yeah.
And what is the measurement for air, like in a tire or in a ball? Does anybody know?
Air.
It says
Pounds
it's
per
yeah. You're there. It has 3 letters. Oops.
CPS.
Pounds
It says PSI. Do you know what that is?
press charges.
And pounds
CSG.
per. Right.
Static electricity.
Pounds per square
static
inch. Right.
Oh, come on.
Most car tires are like 35 pounds per square inch. So at 35, you do PSI. That's usually like what a car tire is. And very often, smaller tires have a higher PSI, which seems counterintuitive. But yeah, like one of my, oh, here's a question for you. Let's see if anybody can figure this out. If you know, you may know. Don't say it if you know, because I've told you maybe. I don't know, Pat. So the other day, like 2 days ago, I went to get day before yesterday, I went to get in my car for the first time since the day before. And remember, this weekend was really warm, and then it was really what? Cold, right? Okay, so I got in my car, and I have one of those things on my dashboard that tells me, uh-oh, one of your tires has low pressure. Nothing poked it, so why is my tire suddenly have low pressure? Does anybody know why?
Because it popped.
No, nothing popped. You want to guess?
Because the cold air.
You're on the right track.
Cold.
Drew, stop. You're distracting.
Can I pick Drew for my
Wait, Eleanor's again.
Because the cold air inside the tire evaporated.
Didn't evaporate, but it did something.
It,
I know what it is.
No, shush. Look at it. Sky?
it did testify.
Compress, contracted. So when things get cold, we're going to be talking about this in a couple weeks too, but when things get cold, they contract, right? When things get warm, especially gas. Gas expands when it gets hot. Gas contracts when it gets cold. So that's why, like, if you blow up a balloon and then you measure it, like you take a tape measure and you measure around it, and then you put it in the freezer and then you measure around it, it's going to be smaller. If you put it in, like, outside when it's hot and measure around it, it's going to be bigger. So the air in my tire, the volume of air in my tire didn't change. Yeah, I mean, same amount of air molecules in my tire. But what happened is it got so cold, and it wasn't even that cold, but cold enough that all that contracted, and then my pressure gauge was like, uh-oh, your pressure's low. And that happens every single year when it gets
really
cold.
Interesting like that happened once when I was on the way back from gym in my grandmother's car. When we parked the car, my dad has a bike stand that has a big bike on it,
Oh, yeah.
and then it went timber.
Yeah, it came down.
And it slammed down on the car. Like, it didn't break anything.
It
but
chips the paint on her car.
It shrunk a little more, which means it
Yep. It was a tension rod that held the bike rack up, and it got cold for the first time, and it came down.
Do you still use your minivan?
Oh yeah, and all the time. All right, so let's finish this last. Hang on, Lily. Let's finish this last paragraph, all right? Because it's nearly time for lab, and those dudes are loud. All right, so weight is measured in newtons, mass in kilograms, and acceleration due to gravitation. So that's meter per second squared. Earth's surface gravitational acceleration is approximately 9.8 meters per second squared, which means that ignoring the effects of air resistance, the speed of an object falling freely will increase by about 9.8 meters for every second until it reaches what?
Newton.
Until it reaches, it's going to keep increasing speed until it reaches what?
Until it reaches equal amount of
Terminal
arrows on both
terminal velocity. Yes, right. Okay. So Newton realized that Earth is not the only object with gravitational force. All objects, give me a second. All objects exert gravitational force. The law of universal gravitation states that the force of gravity acts between all objects in the universe. So objects with a higher mass exert a greater gravitational force and thus pull objects of lesser mass towards them. Now, one of these labs that you guys have for lesson 11, or whatever it is, 10? 10. Hang on. 1 second. I'll get your question, promise. And I'll get Jack's too. One of these labs that I give you to watch shows it. Which one is it? It's the, which one? Oh, I don't know. Anyway, if I don't, I'm pretty sure you guys have it and not just the other class, but it is this guy with a stretched out piece of fabric over a big circular frame. And he puts, like, you know the steel balls we had a couple weeks ago? He puts one in the middle, and then he drops these other balls, and they all go to it, and he circles them around, and you can see gravity actually working. You can actually see it. It's really, really neat. Jack.
So what was going in the final paragraph? I wrote
Newton, kilograms, and Newton. Kilograms, Newton. Everybody have it?
So I got it right.
All right, so the law of universal gravitation in your own words. Does anybody want to give it a try? You want to try it?
Every object in the entire universe, everywhere, has that has mass is some source of gravity. It has source of gravity.
Get
in
gravity
it,
between
but
all
anything
objects.
that
Yes.
has more mass, anything that has more mass. Is there like a specific area of how far out
No, it's everywhere.
gravity goes? It goes everywhere?
Everywhere. Yeah.
Oh.
Wait.
But
And
a smaller thing has less gravity, so something that has more gravity is going to pull it.
Right.
towards it no matter what.
What are you gonna say?
I was gonna say, like, I know, like, there may be other universes, but or galaxies, but
Yeah.
in this galaxy, it's the sun's gravitational pull
Yeah.
with the planets that have their own gravitational pull,
Exactly.
and everything in that pull wants to go to the center of the planet.
Right. So all of our
Because,
planets
like,
are being pulled to the sun,
There's moons
going around and
that
around.
have that's in the gravitational pull that
But we're
also have
also
their
being pulled away.
gravitational pull.
Yes, we are.
So there's like it's not just on the planet's surface; it's
Right.
around.
If you had, say you, who has a little brother or sister? All right, and then, okay, if you have a little brother or sister, pretend that you grab them. And if you have a big brother, pretend he's grabbed you or sister's grabbed you.
Okay.
All right, and then they spinning around and around and around and around and around in a circle and let go, what's going to happen?
You're gonna go
You're going to go flying.
smash your face on
Anybody
the
ever done that with you and you're like, please don't let me go,
Okay.
please don't let me go. Right, okay, so spinning around and around. Right, so here's the thing. If they let you go, you're going to, if they let you go, you're going to fly off, right? Okay, so here's the thing. Here's how the planets don't just fly away, and the moon doesn't just fly away, because gravity is pulling them in. It's the force, it's the outward force, which is the centripetal, the pulling them out, and gravity pulling them in that keeps them in their orbital path. Without that, we'd have a lot of problems. So tell me, somebody, sorry, my throat is so dry from allergies. Somebody tell me real quick, how does friction work when you walk? Anybody over here want to do one? Sky.
What makes you walk?
Right. Your feet are rubbing against ground, and that creates friction. Okay, boys, you may not have experienced this too much. Girls, when you get a new pair of dress shoes, What do you have to do with them sometimes before you wear them out in public?
Rub them.
Anybody ever done it? You've probably done it because you have dance shoes, right? Yeah, what do you have to do?
You have to still wear them around.
You gotta go, yeah, but if you ever go outside and intentionally scuff up the soles on the driveway or something? Because if you don't, what happens?
You'll sweat.
I have a video I can show you. It's outstanding.
All
All right, and then somebody real quick,
There's something else that has
Drew,
special-
hang on. Somebody really quickly tell me, how are weight and mass different? And I'm gonna look up something.
I know.
Go for it, traveler.
So mass is the matter inside of the object, I'm guessing,
Right.
and then weight is the how much it weighs.
Weight is also includes one other thing though. What is it? It's not just, wait a minute, don't give him, no. It's about the amount of matter and mass, but what has to be working with it? Gravity, very good. Okay, I'm gonna show you guys this real quick. I'm gonna find it. This is why you need friction.
Has everyone seen the video of that like stupid girl?
Wait, stop. Don't. All right, so I'm gonna show you. Yeah, hang on. I gotta find it real fast. It's on my Facebook. I should have pulled it up. No. Okay, so this is a very, very, very quick video, but it's like 2 seconds, and we'll watch it really quickly and then we're gonna go do our lab. I gotta find it here. So this is a girl who is, where in the heck is it? So this is a girl who is auditioning for Rent, okay, the musical, and she didn't have the best luck with her audition. Here we go. Okay, hold on. Okay, wait. All right, so hang on. I'm gonna rewind it for you.
Is this the one that Drew was talking about?
I don't know. Okay, so come on over there. Okay, here we go. All right, hang on, wait a minute. I'm gonna make this as big as I can make it. All right.
I have to stand up.
All right, are we watching? All right. Can you see her? This is Newton's law in motion. And this is also what happens when you don't have good where's the volume? It's my volume. This is also what happens when you don't have good good friction going on. You ready? And obviously she's okay because she shared the video herself, so she's all right.
We have to get to lab now. What are you talking about? It's a video about this thing. Really critical. Always made. Like she's talking about how she went to bed. She was talking to the really nice boy who left the video game.
Boy provided the video game for her, and he said the video game was like 25 pounds. And that's like.
Oh, I have one more thing to show you guys too.
Say money there. It was like, but I thought that was kind of a big because I asked how much money.
All right, hang on, Drew. All right, I have one more quick thing to show you. Hang on, Drew. I have one more quick thing to show you, one more quick demonstration, and then we got to get to lab. Okay, so check it out. This is a way to reduce friction. All right. So look, I got two cake pans, right? All right. Can you here, Eleanor, come around right here. All right. Spin that one. Just like give it a spin. Yeah, give it a spin. Just spin it. Yeah, do it again. Okay, not so great. Now I've got some marbles. Now put it. Oh. There you go. So you can actually see it. All right, say goodbye to Jack, everyone. Bye. Not Jack, Jackson. Jack's right there. Jackson. And, all right, take your lab out. Take your lab and a pencil. All right.